Okay. After that, OLTP stands for what? OLTP. There is no voice. Do you hear me? Okay. So OLTP is online transaction processing. Online transaction processing. Good. After that, OLAP is the abbreviation of what? OLAP. Yes, OLAP is the abbreviation of online analytical processing. Very good. Next question. What are the data warehouse models? What are the data warehouse models? Data warehouse models. There are three models. Enterprise data warehouse, the first one. The second one, data mart, and the third one, virtual data warehouse. Three models, not operational, virtual. Okay. Okay, after that, what are the operations performed on data warehouse? So virtual means the view on it or different views. So virtual, that means we will use views to build our data warehouse. To build our data warehouse, we will use a set of views. For this reason, it is virtual. Okay. So the operations are to create our data warehouse are extraction, transformation, and loading. The abbreviation of ETL. So three operations can be used to create our data warehouse. Good. Can you give me some examples of OLAP operations? Some examples of OLAP operations. So an example of OLAP, for example, rollup, or drill down, or slice, or dice, or pivot. So all these are online analytical processing operations. Okay? Good. Let's move now to the cuboid. What's the meaning of cuboid? Cuboid. So we can find apex cuboid, base cuboid, multidimensional. Yes, multidimensional what? database. So cuboid, when we use an ND base cube, this is the base of cuboid. And for 0 dimension is the apex cuboid. Yes, so cuboid, that means we will make a multidimensional data using 0, 1, or n dimensions. So we can build a lattice of cuboids. Lattice of cuboids. So this is an example of a cuboid. This one is also an example of cuboid. So when we have 0 dimension, in this case we talk about apex cuboid. And when we have all the dimensions here, 4 is n dimensions. In this case we will talk about base cuboid. So apex cuboid, that means 0 dimension, and base cuboid, that means 4 dimensions, n dimensions in general. Is clear? Okay. Let's move now to data warehouse design and usage. So there are 4 views regarding the design of data warehouse. 4. We can talk about top-down view, data source view, data warehouse view, or business query view. So for the top-down view, this view allows selection of the relevant information necessary for the data warehouse. And for data source view, exposes the information being captured, stored, and managed by operational systems. For this reason, we talk about data. In data warehouse view, the data warehouse view consists of fact tables and dimension tables. So there are many or different conceptual modeling of data warehouse using fact table and dimension table. For example, we can find star schema or snowflake or galaxy schema, etc. The fourth one is business query view. So see the perspective of data in the warehouse from the view of end user. For this reason, we talk about a business query view. So there are 4 views: top-down view, data source view, data warehouse view, and business query view. Let's move now to the design, design process of a data warehouse. Design process. So fact here only in data warehouse view. Yes, that means when we see data warehouse with data warehouse view, we will talk about fact tables and dimension tables. It depends how we can make our view. So for data, for example, if our view is about data, we will talk about information captured, information stored, etc. But if our view is a data warehouse, in this case we will talk about only fact table, dimension table. If our view is a business query, in this case we will see the perspective of data from the view of end user. It is clear? Good. So for a design process, there are top-down, bottom-up approaches, or a combination of both. The second manner, from software engineering point of view, we will see another design process. So top-down starts with overall design and planning, but bottom-up starts with experiments and prototype. The first one is mature, the second one is rapid. So from software engineering point of view, we can find waterfall or spiral. So the first one is structured and systematic analysis at each step before proceeding to the next. For spiral, the rapid generation, short turnaround time, quick turnaround, etc. So a typical data warehouse design process shows a business process to model, for example, orders or invoices, etc. After that, choose the grain, atomic level of data of the business process. Choose the dimensions that will apply to each fact table record, and choose the measure that will populate each fact table record. For the development, this is the recommended approach. So we have here a multi-layer data warehouse, an enterprise data warehouse, data mart here, data mart, and distributed data marts. So we will define a high-level corporate data model with a cycle here to make a refinement of a data mart here also. After that, this data mart will be distributed and used to a multi-layer data warehouse. So also the enterprise data warehouse can be used for a multi-layer, multi-tier data warehouse. There are many usage for data warehouses. The first application is information processing. The second one is analytical processing. The third one is data mining. So for information processing, for example, we will make some query, some statistical analysis. We can create some reports using cross tables, some graphs, etc. So this is the first application. The second one, analytical processing. So in this case, we will make a multidimensional analysis of data warehouse data, and to make it, we can use some all-up operations like slice, dice, drilling, pivoting, etc. The third data warehouse application is data mining. So knowledge discovery from hidden patterns. We want to extract some information, some knowledge from our data warehouse. And in this case, we can make, for example, we can perform classification and prediction. We can make association rules. We can construct analytical models, etc. It is clear? Any questions? So from online analytical processing to online analytical mining. So the question is, why online analytical mining? Why we want to perform data mining in our data warehouse mining? The question is, why perform data mining? So there are many reasons. The high quality of data in data warehouse. Why the quality is high in data warehouse? Why? Why the quality is high in data warehouse? Yes, very good. Because the data is cleaned data, very good. So a data warehouse contains integrated, consistent, and cleaned data. Also, there are are you here? You heard me? Okay, sorry. So available information processing structure surrounding data warehouses. So we can find ODBC or OLEDB, or the abbreviation of object linking and embedding database, web accessing, reporting, and OLAP tools. Also, we can use OLAP to analyze the data, so we can, for example, make mining with drilling or dicing or pivoting, etc. We can also make integration and swapping of multiple mining functions, algorithms, and tasks. So for all this reason, it is very interesting to apply data mining on data warehouse. Let's move now to data warehouse implementation. So efficient data cube competition. So data cube can be viewed as a lattice of cuboids. The bottommost cuboid is the base. So for base cuboid, how many dimensions? For base cuboid, how many dimensions? N. And the topmost cuboid, how many dimensions for the apex? عليكم السلام ورحمة الله وبركاته. ما في مشكلة. So for the apex, 0, and for the base, not 4 but n in general, n. In this example 4, but in general n. N is the number of dimensions. Okay. Okay. So, how many cuboids in n-dimensional cube with L levels? So, to compute the number of cuboids, we can use this formula. So, T equals the product of I equal 1 to n Li plus 1. So, what's the meaning of materialization of data cube? Yes. Yes. So, materialization, that means we will make storing, yes. We will make storing, we will save. The data will be physic, not a view. So we can materialize everything. In this case, we talk about full materialization, or no materialization, or some partial materialization. So in this case, why we will materialize a part, just a part? Why? Why we will materialize just a part? Because the data warehouse is big, it's very big. We talk about terabytes, 100 terabytes, for example. For this reason, we will not materialize all the data, but just a part. Yes. So in this case, we have to select of which cuboids to materialize. And this selection can be based on size, or sharing, or access frequency, etc. Yes? Mr. Abdulaziz, you have a question? Okay, let's move now to how we can compute a cube, compute cube operator. So this is the manner to cube definition and competition in DMQL. DMQL is the abbreviation of data mining query language. So to compute a cube, we write define cube, like create table, but here we write define cube. Okay. After that, the name of the cube. After that, the dimensions of this cube. In our example, we have how many dimensions? 3. After that, here we will use what measure. For example, here we will use the measure sum, says in dollars. This is the definition. Okay. The first line is to define our cube. After that, the second is to compute our cube, compute cube cells. It is clear? Okay. We can make the same compute cube by in SQL SQL-like language, not SQL language, but SQL-like language. So there is a researcher, Mr. Gray, and all. He proposed a new operator, QBY. So QBY, this is a new operator, like group by in SQL, but this is a new operator. So in this case, when we want to define this group, we write select item, city, year of sum of amount from sales. After that, we write QBY. QBY item, city, year. Okay? So when we write QBY, this QBY, we need to compute group by data product customer. After that, group by data product, group by data customer, group by product customer, group by date, group by product, group by customer. It is clear? Any questions? It is not clear? Ahmed? Not clear. No. Here we have not to. Okay, just a moment. Here we have not to create all the possibilities. To list all the possibilities. So the result of this query, is to create a cube. We want to create this cube. Okay? We want to create this cube, this one, for all the levels, with all the possible combination. It's clear? So in SQL, when we write create table, the result will be a table like this with columns. So columns here, the different attributes, and rows. So rows are the different tuples. After that, we will insert tuples as rows in this table. It is clear? But for our case, when we write define a cube and compute a cube, we will obtain a multidimensional data like this with the different possibilities. That means we will obtain, for example, data product customers with the sum, this combination, etc. So for example, here we have how many possibilities? For three dimensions, we have 1, 2, 3, 4, 5, 6, 7, 8. 8 possibilities. Okay? But here we don't need to compute all the combinations. If we write QBY, automatically we will compute all the combinations. Sorry. So if we write QBY, that means we will compute all the possibilities. It is clear? Okay. Let's move now to indexing OLAP data, bitmap index. So what's the meaning of bitmap index and how we can create this bitmap index? Bitmap index. So it is an index on a particular column. For example, this in our example we have the column region and the column type. So how to create this index? We will prepare our index with the possible values of the column. So for example, for region, what are the possible values here? For region, what are the possible values? We have Asia, Europe, and America. 3. So these 3 possible values will be, or we will create 3 columns like this, and after that we will make a binary code. For example, the first customer 100. That means for the first customer the region is Asia. For the second customer the region is Europe. For the fourth customer the region is America, etc. It is clear? So to create the index of type, we will use only 2 columns because type has only 2 possible values. This is how we make indexing the data, indexing OLAP data with a bitmap index. After that, we can make a join indices, and we can also make efficient processing OLAP queries. So determine which operations should be performed on the available key bytes, transform drill role, etc. into corresponding SQL and OLAP operations. For example, dice is a selection plus projection. After that, determine which materialized key byte should be selected for OLAP operations. So here it depends of, for example, the frequency of the access to this cuboid, etc. So there are 4 OLAP server architectures: relational OLAP, multidimensional OLAP, hybrid OLAP, and specialized SQL servers. Okay, just a moment. I want to save the attendance.